In this video, we're going to be talking about composition functions. So with composition functions, basically what it's saying is that you have a function inside of another function. So like when you see the symbol f of g, this O here represents of. So when we see this O here, this is f of g. And what this means is that the g is being plugged into f. So as you can see here, g is being plugged inside of f. And if you see golf or g of f, that means f is being plugged into g. As you can see here, f is inside of g. So let's see what that looks like when we're working out problems. So as you can see here, for f, this one says f of g, so that means you're plugging g into f. So as you can see here, g is going to be plugged into f. So here is my f function. It's just a square root of x, but what it's saying is that instead of this x, we're going to plug in all of g in for that x. So when we write this out, it's going to look really weird, but you're going to take your f function, and wherever you see an x, in that case right there, you're going to be plugging in your g. And so I have to plug in x minus 1 into x, and so that's going to look like x minus 1. And then from there, you're going to try to simplify. Now, there's not much to simplify here. I can't combine x and minus 1, so you're done. This is it. For the next part here, for g of f, you're plugging f into g. So if you go to the g function here, or sorry, this one here, notice that x is right here and there's a minus 1. So instead of this x, what you're going to be doing is plugging in this square root of x. That's what f is. So we're going to make an outline. Our g function is x minus 1, but we're not going to write this x anymore. Instead, we got to plug in our f function because that's what we're plugging in. So notice that f of g, you're plugging in f, so I'm going to plug in all of this. So that means the square root of x goes here instead of x. And now that is it. You are done because I can't simplify a square root, or I can't combine a square root of x with a constant, a 1. All right, so from there, let's take a look at these. So these are composition functions as well, but you're plugging in an actual number. So what you do is you take your equation. Now, lucky for us, we've already found f of g, so here it is. And so what we're going to do is rewrite our equation, x minus 1. But instead of the x, we're going to plug in our 2. So x here is our 2, so we're going to plug in 2 minus 1 inside and then work this out. So that'd be the square root of 1. 2 minus 1 is 1. Square root of 1 is 1. And so that is our answer. Actually, it's a positive plus and minus 1. I forgot to mention that. So plus and minus 1. All right, and then this one here, we're going to do the same thing. We're going to take our f function again, since it's saying f of g. So that's the square root of x minus 1. But wherever we see our x, we're going to be plugging in 4. So we have square root of 4 minus 1. And working this out, this is the square root of 3. And we can't simplify that, so we'll just leave it like this. We can say that it's a plus and minus since you're going to be taking the square root of that. There we go. So for this one here, notice that this parenthesis symbol is saying f of g, since g is inside of f. So this 0 here is representing our x value. So basically, take your f of g function, which is the square root of x minus 1, and plug in 0 for x. So that would look like square root of 0 minus 1, and you'll work it out. So 0 minus 1 is negative 1, and then this would give you an imaginary number. Because in this case, square root of 1 is 1, but you would have an I since there's a negative number here. So I will just put the imaginary symbol, which is the I. So that would be my final answer. I'm not going to give out problems like this one since it's a little bit wonky and a little bit weird to see imaginary numbers, but I thought I'd show you that just as a refresher. And then this one here is G, and inside is F. And again, so that's our X value. So this time we're going to take this equation, since it represents this guy here. So instead of the square root of X, we're going to put square root of 0 minus 1. And so square root of 0 is 0. Minus 1 is negative 1. So that would be my final answer. Alrighty, so let's get into our last part here, which is looking at graphs and following its combination. So if you want to do a problem like this, remember that when it comes to a graph, you're going to be looking for the corresponding, like if you're given an x value, you're going to be looking for its y value. So first off, let's first understand that this is f plus g. So another way you can see this type of equation, or f plus g, is if you go back to the definition here, notice how f plus g can also be represented as two separate equations and then separately added. So in this case, that's what we're going to try to do, is rewrite it in this format because it's a lot easier to interpret when we have a graph. So if you have this case here, let's rewrite this out as f3 plus g3. So I'm going to write it separately because I have two graphs here. I have a f graph and a g graph. So if I go to f3, this is my x value. So at 3, my y value, or my f of 3, is at 1. So my first equation is at 1. G of 3, if I go to 3 for g and I go up, it's at 2. So now that I've solved for the y value, I can add these two numbers together, and so my answer is actually a 3. Okay, so that's what we're going to do, is just find the f and g values separately and then combine them. So this one here, you have your f value, so that's like f of 2 divided by g of 2. So if you were to find f of 2 first, which is right here, notice that the y value is at 0 since it's laying on that x-axis. So I have 0 for f. For g of 2 is at negative 1. But if you have 0 on the top and you divide, the whole answer will end up being 0. This one here is multiplication, so it says f times g, so let's rewrite it as multiplication. So f of 3 times g of 3. F of 3 I think I found earlier, which was a 1, and g of 3 I've already found too, as it was a 2. So 1 times 2 is what I'm going to do, and 1 times 2 is 2. For the fog, or f of g, remember that is taking your f, plugging in a g, right? And in this case, our x here is going to be the 2. So first, I would do this one by one. I would first try to find out what g of 2 is. So g of 2, you go to g of 2, is right here, and it's at negative 1. So then this here would be a negative 1. So I figured out what g of 2 is. It's negative 1. Now I'm going to find what f of negative 1 is. So if I go to f, and I go to negative 1, it's right here, notice that the y value there is 0. So this here is going to be 0, and that would be my final answer. So when you're doing composition functions, I like you to think of it like an onion. You're almost like going to the core, and you get rid of that, and then you keep moving outwards. So you go from the core, figure out what that number is, then take that number and figure out the next layer, and keep going until you've gotten all the layers. So like this one here, I'm going to rewrite it as the parenthesis form, because that's what really helps me, is when I rewrite it as a parentheses. So this is g of f, so f is going to be on the inside, and the 2 is going to be on the very inside here. So f of 2 is, let's see, on our graph. So this is 2 for f, and that's at 0. So f of 2 is 0. Now it's saying go find 0 of g, so 0 is here for g, and the value for g there is 4. So in this case, my answer here is 4. Last but not least, this is f of f. So if I were to rewrite it as a parentheses, this is going to be f of 4. So again, the inner layer is going to be on the inside. So basically the number furthest to the right is in the inside. And then we have to find f of 4 first. So if you go to 4 on the f graph, it's going to be at, let's see, 1, 2, 3, 3. So this is going to be f of 3. And then I have to go find what f of 3 is. So again, going back to the graph, f of 3 is at positive 1. And that's it. That is our journal for here. So hopefully that helped you out with composition function. Make sure you look at the practice problems to get some extra help. Bye, guys.